Hi, Assalamualaikum. My name is Ahmad Zulaika binti Abdullah, AD 250063. I'm from Section 2 and as a presenter 1. So today we want to present about the structure operational flow of the experimentary, focusing on the heat process, instrumentation, circuit at the reservoir. The entire workflow starts at the pre-operational phase. Before interacting with any active plant machinery, the process flow strictly demands an intensive study and breakdown of the PNID blueprint for the heating VE203 process. This theoretical understanding maps of how the inner vessel containing the chemical sample interact with the surrounding heating jacket. Once of the layout diagram is verified, the flow transitions immediately into the mechanical line tracking phase. Operator deployed to the plant floor to physically trace the mechanical pipeline and the heat transfer liquid routes surrounding the reactor jacket, ensuring that the physical piping line completely aligned with the engineering drawing. 1.
Assalamualaikum, my name is Asha binti Abdullah and my metric number is AD250188 from Section 2. Moving forward from the mechanical routing, the process flow advanced seamlessly into the electrical circuit line tracking and instrument audit phase. At this stage, the operation shift focus to tracing low voltage control loops and electrical power distribution. The flow requires mapping the electrical signal routes and wiring connection that link the field instrumentation to the control station. Concurrently, a rigorous instrumentation audit is executed to map the core physical components. This involves checking the physical location and state of the temperature sensor, the temperature control valve, the reservoir, and the circulating pump. During this phase, walkie-talkies are verified and kept active to establish a seamless communication link between field personnel and the control room operator. Hi, my name is Nura Adana at metric number AD250178 from Section 2. Once the physical, mechanical and electrical circuit are verified to be safe and intact, the execution flow enters the sequential power-up phase. In this phase, maintaining a strict chronological order is vital to safely initialize the automation layer. The flow begins at the power source by switching on the molded case circuit breaker MCCB to energize the main electrical rate. Instantly following grid power stabilization, the process transitions to the control tier by switching on the PLC system. This boots the central programmable logic controller responsible for balancing rapid heat up and cool down dynamics. Finally, the sequence culminates in switching on the SCADA control system, which fully boots the central graphical user interface and open up real-time monitoring of live temperature readings and valve positions.
Assalamualaikum, my name is Raja Fakrusha, metric number AD 250153 from Section 2. With that thermal loop fully live and monitored in real time, the final phase transitions to data mapping and system optimization. The process flow requires the precise technical sketching of the heating process, instrumentation, so control circuit. This step documents how the temperature sensor signals feed into the PLC module, update on the SCADA interface and actuate the temperature control valve. This comprehensive data flow serves as the raw materials for the ultimate engineering mandate, redesigning the control system of the heating process. By re-engineering the mechanical and electrical circuits, operators string a highly optimized, safer and more stable thermal control loop. Navigating this exact sequence from PNID analysis to automated stabilization and schematic redesign completely fulfills the industrial learning outcomes of this instrumentation experiment. Thank you.